Good morning. Today, I'm going to go back to the basics. One of the main points of Creative Anger is for this channel to be at least somewhat educational. My goal with this video is to help give a beginner some insight as to the core thought process of designing something useful in CAD that will be 3D printed. I'm going to build a very basic yet functional item today. This tutorial isn't designed to be complicated by any means. It's designed to help you open your mind and show you various things to consider while designing a product. To show how different parts of a product may interact with each other, to show some basic limitations of 3D printing, and how to work around them. Today, I'm going to teach you how to build a 3D printed set of miniature storage drawers. This video won't be anything fancy or complicated. That being said, it's hot as hell in here today. Let's roll the intro so I can get inside.
Alright, now that we're back, let's talk for a moment about today's project. Why did I pick miniature storage drawers as our first project? Well, there are a few good reasons. Reason number one, there are many designs available that various manufacturers use that all offer similar yet different benefits, meaning there's a common product you can study. Reason number two, they have moving parts. It doesn't matter how basic they are, there are multiple parts that interact with each other. And reason number three, structure and planning is important. For example, selecting the wrong wall design or wall thickness can cause the whole unit to flex. If your margins are too small, this can cause your drawers to get stuck. There's no denying that today's project is simple. But my goal is to show you that even with something this seemingly basic, there are many things to take into consideration to create a product that happens to be both durable and reliable. There are two extensions necessary for this product, Stl Import and Export and Solid Inspector 2. These two extensions are absolutely free and they are critical for 3D printing. They are a requirement for this project to work as expected and they are linked below. Let's start at the beginning. We already know what we're building, so how big should each drawer be? I used calipers to measure out a few drawers from different brands that I have laying around. They appear to be about 50 millimeters wide, 35 millimeters tall, and 130 millimeters deep on average. I'll stick to the same height and width for our project, but I'll make them 70 millimeters deep rather than 130 to save time in the printing process for the sake of this video. You can make them whatever size you want. The overall concepts are the same. Most parts drawer kits you find at Home Depot, Walmart, Harbor Freight, etc. come with 30 drawers or more. So how many do we want to use? For this project, I'm going to say 7. Using the drawer sizes mentioned, we can comfortably fit 7 drawers in a 3x1x3 configuration on my printer's build plate. 6 drawers being 50 by 35 by 70, and 1 drawer being roughly 157 by 35 by 70. Okay, we know how many drawers we want, so we can figure out what parts we need to print. We'll need to print 1 caddy to hold the drawers, 6 smaller drawers, 1 large drawer, and 7 knobs to install on the drawers. It's time to whip out a CAD program and start designing the caddy. For these projects, I'm going to stick to SketchUp. Even though I've got proper CAD software, this video series is for beginners. Sticking with a software solution that's both free and simple is an excellent place to start. When first launching SketchUp, I prefer to use the template Woodworking Millimeters. I don't use the 3D printing template. I want a blank canvas, not what the software assumes is the size of my printer as boundaries. The first step to creating the caddy is to create a grid using the tape measure tool. This allows us to predefine our wall thicknesses and drawer sizes in an easy way. I've gone with a 1.5mm wall thickness. It's not so thin to where it flexes too much, but it's not so thick that it will take a significant amount of time to print. You'll hear me reference 1.5mm very frequently in this video. Since we know we're going to be laying out 7 drawers, I'll first set guides for the vertical lines that will become the outer walls and supports. Off of the green line, I'll mark out a parallel line at a distance of 1.5mm. Since I know my drawers will be 50mm wide, I'll leave 1mm on either side of the drawer for smooth movement. That means my next line will be at the 52mm mark. I'll once again set a 1.5mm mark, then another 52mm mark, then another 1.5, then another 52, and a final 1.5mm mark. That completes the guides that make up the outer vertical walls. Next, we'll lay down the bottoms of the walls. Off of the red line, we'll go 1.5 millimeters on the green axis. That gives us the very bottom of the unit. Since we know the drawers will be 35 millimeters in height, we'll mark out 36 millimeters. Then we'll mark out 1.5 millimeter walls using the same pattern as we did on the verticals. Then we'll go another 36, then 1.5, then 36, then 1.5. This will leave us with a grid that contains 9 cells. We only need 7, but we'll get to that shortly. Now we need to use the pencil tool to draw lines for the outer boundaries of the caddy. We'll go from the point of origin up the green line to the final guide, then all the way right to the final guide, down to the red line, and back to the point of origin. Next, we'll start tracing over the guidelines on the top and the bottom row only, ignoring the middle one for the time being. You can use the pencil or the rectangle tool to perform this action. Once traced out, you're going to grab the width of the entirety of the 3 cells to build the center drawer. Provided you did everything properly, you should be able to delete the guides and end up with a sketch that looks like what you see here. Excellent. Now that we've got all of the cells marked out, we're going to want to grab the push-pull tool. We'll grab the gap in between the smaller lines and pull the structure towards you by 72 millimeters. Now you can grab the select tool and remove the walls in the back of the caddy. A very important feature of this caddy will be its ability to disallow the drawers to be pushed through the back of it. You don't want your parts just falling out, now do you? We're going to grab the tape measure tool once again and mark out 2 millimeters from the leading edge of each row. Once marked, we'll grab the pencil tool again and mark off the end stops permanently. Once the lines are drawn, remove the guides and grab the push-pull tool again. We're going to extrude these little sections to use them as barricades to keep the drawers from falling out the wrong side of the unit. A 2 millimeter height should be perfectly fine as there's only 1 millimeter of wiggle room on the vertical space. The drawer should not be able to pop over this stop. Technically speaking, as of right now, we have a fully functional caddy. But since this is about product design, let's make a few tweaks to make it a little bit more appealing to the eye. Let's give it some curves. I'm going to go ahead and rotate my view to face the other side of the caddy. What I want to do is give the caddy some curves to style it up just a little bit. Look closely at where I draw these lines. I want to convert the horizontal shelves into unique segments. Next, I'll grab the 2-point arc tool. I'll draw a line from the left side to the right side, then along the blue axis, I'll pull a line towards myself by 5 millimeters. I'm going to repeat this on all 4 shelves. Next, I'm going to use the push-pull tool to once again extrude these rounded sections by 1.5 millimeters to level them out with the shelves themselves. And lastly, I'll grab the select tool again to remove the extra lines left over by the process of adding in the curved sections. Removing the extra lines is not a requirement, but it is good practice. Finally, I'm going to select the entire caddy and convert it into a component. I'll name this component Caddy. It is time to use our first extension, Solid Inspector 2. With the component selected, click on Tools, and then Solid Inspector 2. Depending on the order and direction in which you extrude its surfaces, you may find that there are stray edges, internal faces, or reversed faces. This is perfectly normal when modeling in SketchUp, and in most cases, it wouldn't cause an issue. However, in 3D printing, it's very important to fix this. I strongly recommend fixing each category one by one rather than hitting Fix All to help you see what's being changed. That way, if something drastic happens, you're more likely to see why. If you'd like, this is an ideal time to colorize the caddy a bit. I have to make it look a bit prettier on screen, but that's by no means necessary and doesn't affect the functionality of the project. At this point, we're going to go ahead and create 4 layers. One titled Caddy, another one titled Large Drawer, another one named Small Drawers, and a final layer named Knobs. We'll go ahead and select the caddy component and under Entity Info, flip it over to the caddy layer. Then, while we're still on our working layer, or layer 0, we'll go ahead and shut the visibility off for the caddy layer. Now we're going to move on to the large drawer. Since we've rotated the view by 180 degrees, we are now going to be working from right to left instead of left to right. Using the rectangle tool, let's draw out a box that's 157 by 70 millimeters. We'll use the push-pull tool to extrude the rectangle we drew to a height of 1.5 millimeters. Next, we'll grab the offset tool and bring in the outside edge by 1.5 millimeters. Finally, we'll grab the push-pull tool again to raise the height by 33.5 millimeters. On the front side of the drawer, we're going to use the tape measure tool to locate the dead center of the front face. We'll then use the circle tool to draw a circle with a radius of 1.6 millimeters. We'll now use the push-pull tool to push the circle inwards and create a tunnel from one side of the wall to the next. And we now have our large drawer. Let's go ahead and select the entire item we've just created, and once again we'll convert it into a component named large drawer. Colorize it as you want, and dump it onto the large drawer layer. We'll go ahead and hide the large drawer layer just like we did the caddy. We still have more parts to make, so let's go ahead and start on the small drawers. We're going to go ahead and do the exact same process again, but this time it's going to be 50 millimeters by 70 millimeters. Once drawn out, we'll use the push-pull tool once again to extrude the entire layer up to 1.5 millimeters in height. Then, we'll use the offset tool once again to pull the outer edge in by 1.5 millimeters. We'll flip back to the push-pull tool again, and bring the outer walls up by 33.5 millimeters. We'll go ahead and use the tape measure tool to go ahead and mark the dead center of the drawer, and once again, we'll use a radius of 1.6 to draw a circle in the middle, and we'll use the push-pull tool to hollow it out. Same as before, we'll go ahead, select the entire object, make it a component titled Small Drawer, and we'll colorize it to match the rest of it. We'll take this object, flip it over to the small drawers layer, and we will go ahead and hide that. Before we move on to finishing the model, I want to go ahead and re-enable the large drawer once again. I want to run Solid Inspector on the drawer to make sure that there are no conflicts in the model itself. Since this one is perfectly fine, I'm going to go ahead and hide it again, and I'm going to select the small drawer. Once again, no errors have been found. At this point, the caddy, the small drawers, and the large drawer have no modeling errors. So I'm going to go ahead and create the knobs. The knob is going to be very simple. It's just going to be an extruded circle. I'm going to come off of the blue axis, following the red axis by 10 millimeters, and I'm going to come off of the red axis, following the blue axis by 10 millimeters. I'm going to grab the circle tool and create a circle that is 8 millimeters in diameter or a radius of 4 millimeters. I'm going to use the push-pull tool to bring it towards me by another 8 millimeters. I'm going to flip back to the rear of it where the intersection is. And you remember how we wanted 1.6 millimeters earlier? This time, we're going to punch in the appropriate 1.5. And I will also use the push-pull tool to extrude that circle by 1.5 millimeters so it matches the depth of the wall that this will be inserted into. Remove the guides, turn it into a component, and color it however I feel. I'll flip this over to the knobs layer and hide it. Congratulations, all of the design work is complete. I've gone ahead and finished up the file visually, but what I've done has no effect whatsoever on the finished product. Since we haven't saved the project yet, let's go ahead and do that. We'll create this project its own folder. I'll call it Caddy. Inside that folder, I'm going to create 3 other folders: Components, STL Files, and G-Code. I'll name the master file Storage Drawers. For good measure, I like to export each individual component as its own SketchUp file. These files get stored in the Components folder. Next, we need to create an STL file for each component. We'll open each component file individually, then we'll go to File, Export STL, set the export unit to model units, the file format to ASCII, and click Export. This file should get stored in your STL Files folder, and this process should be repeated for all 4 components. Using the individual component SketchUp files ensures the point of origin information remains consistent from part to part. This makes setting up your slicer software such as Cura significantly easier to manage. At this point, we can crack open Cura and start slicing up our models. Once Cura is loaded, you open up your Stl files starting with your CAD. Due to its size, you likely won't be able to print much other than the CAD at the same time. One thing to be aware of is the direction the CAD sits on the build plate. You may need to rotate it by 180 degrees to ensure the curved side is facing up. I'll be honest, I printed out the CAD for demonstration purposes. I used pretty poor settings, and it's a hunk of crap. It's not even worth showing. My layer adhesion is horrible because I was trying to save time for the sake of completing this video. That's my fault, not the fault of the model. Model should work perfectly fine. So here's a quick conclusion. Can you just go to your major big box retailer and purchase a set of drawers? Absolutely. And quite honestly, I'd recommend that. But in the end, this isn't intended to be a replacement for the products that you can purchase. This is intended to help you learn how various things interact with one another. Take this project one step further. Add curves to the drawers to follow the curvature of the CAD. Take it to the next level and show it off. Maybe we'll showcase your revised design in a future video. Do you have any specific questions, comments? Please let us know below. Like this video? Smash that thumbs up button. Want to see more? Click subscribe. And until next time, see ya.